Okay.
Start the recording.
I've got the recording going.
Since you asked us.
If I screw nothing out, if I screw anything else up today, at least I got that right.
Hey, Lloyd, don't
Yep.
forget to start the recording.
Thank you.
Are you sharing your screen? I can't
Not
tell.
yet. I'm about to.
I'm sure I don't have like a setting wrong.
Okay, hang on. My screen is doing strange things to me when I try to share with this setup. Okay, let's try this again. And that one. And there we go. Okay. Okay. Nice. Everybody see that okay?
Yep.
Okay. Why? There we go. Okay. Now we got it. Okay, welcome to the May 2025 meeting for the Seattle Robotics Society. Let's see. Videos provided by Zoom. For folks, we record all of our meetings and we post them to YouTube later. So for those folks who couldn't make it, you can still watch the videos. And pretty much just our standard run-of-the-mill agenda. We'll kind of do the welcome club business and so forth. Please mute your microphone unless you're actively sharing. We'll also use the Zoom chat to ask any questions, comments, post links, etc. The chat session is captured and will be posted along with the video. Please don't share any proprietary information. We don't have to, go through all the paperwork of having to kill someone afterwards because they found out things they shouldn't have. Okay, myself, Chas, or Steve, or Donna is kind of running the meeting, so we're kind of moved to a format where we're kind of rotating around and taking turns. Steve is still scheduling the presenters and updating the website each month. We do have a new item this month. So folks that have been around a while remember in the past we used to do t-shirts, and we've done various things over the years. So we're bringing that back, but in a different form. One of the problems with doing t-shirts is anybody's ever done them, you have to kind of know what to buy and how many to buy and buy them ahead and all this. We've moved to a print-on-demand style of model, and that actually lets us do a lot more than t-shirts. So we've signed up with Redbubble. The link is at the bottom. The QR code will take you to our SRS Robothon shop. And you can now get t-shirts, mugs, duffel bags, hats, notebooks, cell phone covers, mouse pads, stickers. It's really easy to set all this stuff up. So if folks would like to do that, that would be great. And if you happen to get one and wear it to our, you'll be all set for the May 31st Robothon event. So that's how we're bringing this back. The other thing is,
to see that.
Yeah, the other thing is this is available. We're going to do this all year round now. So it's not just going to be, like when we used to do Robothon at the Seattle Center, it was pretty much just a Seattle Center event and then just our meeting events. Now this is up there 24/7. Anybody can do it, including if they're in our club or not. And, we'll generate a little bit of funds for the club that way. So feel free to get your swag and tell your friends. How's that? Okay, Donna has started a new group called Build It with Arduino. The next meeting is Saturday, May 24th. It will not be May 31st because we're all going to be at the Robo Magellan or the Robothon thing, including Donna, who's also doing a presentation. So I know she's not doing this next on the 31st. So the next one is May 24th for Donna's Build It with Arduino. Yeah, geez, this slide got a little munged. Uh, anyway, our spring Robothon event is going to be May 31st at the Kent Fieldhouse. If you go to, this slide is a bit munged. If you go to Robothon, robothon.org, which should be the QR code here. If you go to that, that's got all the times, the schedules, the robots that are signed up, the address of the field house, everything. So that's coming up at the end of the month. For folks here, Chaz and I were talking. My company will sponsor kind of some coffee and donuts and stuff in the morning, and then Chaz is going to do a pizza thing at lunch. So there will be food, basically just like we did last year. And if folks buy T-shirts, then we'll use that money for these things too.
Bravo.
I plugged the T-shirts enough. I'm back to hawking T-shirts. Okay, we've got
Lloyd.
Yeah.
So I think Donna canceled the May meeting for her.
Oh, she did. Okay.
So probably partly because we're having the Robothon, but also she probably couldn't have done the week before. So yeah,
Okay.
the next one is 6/28. That'd be June 28th.
June 28th. Okay. Okay. Thank you. Somehow I did not get that message, but that's okay. I'm usually the last one to hear about these things. Anyway, we have a set of local makerspaces. Visit the SRS homepage, select resources and makerspaces. Chaz runs the one up on the north end. Do you want to put a little plug in there, Chaz? Since we're, I'm hawking T-shirts like crazy, so I might as well let somebody else hawk other stuff.
Other stuff. I would encourage you to visit whatever local makerspace you have. I think that they're really nice for connecting with people with similar interests. If you happen to be in the north north of Seattle, I think our makerspace is very nice. It has a lot of tools and great community. However, I know there's a lot of other makerspaces out there, and just encourage you to reach out. And it's a great place to learn new things, especially around robotics, CAD, mechatronics, electronics, etc. So, yeah, it's a something we didn't have, back when I was a kid or young adult, and it's a whole new world, and it's a really cool place to hang out for us nerds.
Okay, thanks, Chaz. And well, actually, there's a logo for the Sunoco Makerspace. Does anybody want to talk about past events or other events that you've gone to? I mean, we had the Northwest Model and Hobby Expo last month. That was a lot of fun for folks who got up there.
Yep.
So we'll go to this one. Anybody have anything else that you want to touch base on for past or other events?
Yeah, no, just mentioning that for the Hobby Expo, we were able to have a booth up there for SRS and for the Sunoco Makerspace. We were right next to each other. That was a lot of fun.
Yep. Yeah, I think I missed you, Terry. I was only there for one day because we were out of town for a couple. So
I was there Saturday, and then I bopped in just briefly Sunday, but I had to leave. So
okay.
Yeah.
I was only there Sunday, but I missed you guys. I did manage to catch up with the war group though, so I hadn't seen them in a while.
Mm-hmm. Yeah. That's Western Allied Robotics for people who may not know.
Yep.
They had a BattleBot arena up there as well. The Northwest Hobby Expo has a lot of RC cars, planes, trucks in competition up there, and boats. And it's a fun event. It's a yearly event, but it's usually 3 days, Friday, Saturday, and Sunday. This year, I can't remember if it might have only been 2 days.
No, it was 3 days as well.
It was, okay.
Yeah.
But it's yeah, it's a lot of fun if you have an RC hobby involved with things too.
I was there Friday and saw two things I really liked. One was what what do you call them? They're airplanes. They have they had the um uh center of the hall blocked off with fences, and they had
Oh
airplanes
yeah,
flying around in there. Very, very light styrofoam airplanes with way extra amount of power on the propellers, enough that they could actually just float like a helicopter on their propellers.
yeah.
Yeah, I think that was called the lighter than air category of
Okay.
craft.
Right.
Yeah.
And then the other that I really enjoyed were the oh, what do you call them? Heavy equipment. Um
Oh yeah.
Road graders. I don't know if they had road graders, but they had
Yeah.
tractors and uh, bulldozers with some of them that were treaded. Many of them use actual hydraulic actuators
Wow.
for everything, except that they didn't use hydraulic motors for the wheels, but they used electric for that. But and they had their taillights and headlights. Everything was operated on the RC, I think.
Mhm. Yeah, they had a good representation of the construction RC equipment.
Yeah.
In years past, they've also had indoor drone racing. I don't
Oh,
remember
cool.
seeing anything about that this year,
Yeah, I didn't see
but
anything for drones.
yeah,
Although it's a large racetrack that was actually laid out on the floor of the building. So all they did is like put up berms and stuff like you would on a real racetrack. And they were racing. At first, I thought it was a big slot car track, but then when I looked closer, I realized those were RC cars racing on and, it wasn't just an oval. It was had an S-shaped part to it, and pretty cool.
Yeah.
yeah, and they have a drift racing category too, where they do it on the smooth floor, but it's all about getting the car to slide sideways
I
as it
think
goes
that's what
around
I'm
the
talking
course.
about. Yeah. That's what I was talking about. Yeah.
Okay,
Oh,
so
okay.
they actually had two of them. One was the drift,
Oh,
and then in another building, and I think it was actually on carpet or something.
It is
They had
carpet racing.
another,
Yeah.
they
no.
had another big track with ramps and jumps and berms and all kinds of stuff. Both were pretty fun to watch. The other one I'd note, they also had a swap meet up there, which I don't know. It looked by the time I got over to it on Sunday, it looked like they were kind of starting to filter out. But
Mhm.
just a warning for folks: the swap meet would be really dangerous to go to if in full on. They have a lot of they had a lot of things there that it's like I'm leaving now or I'm coming home with more stuff than I really need.
Yeah. Yeah, they have the swap meet up there once a month, and they make it coincide with the Northwest Hobby Expo when they
Oh,
schedule.
interesting.
Oh,
Oh,
yeah,
okay.
each
So the
year.
swap meets, okay.
Yeah, it's ongoing.
Oh,
I believe. They didn't change that, did they, Chas?
I don't know, but I know like that day is usually mostly just RC and hobbies and that sort of stuff. So I think
Yeah.
everybody just realizes that's what's going to be there, but not in the same building. It's like across the way.
Yeah. I
One.
walked over there. Yeah. And they have RC boats as well, and not just small ones. They have ones that are military style that are really large that they use for water-based battles as well, where they're shooting ball
mhm.
bearings at each other and annihilating the other boat.
So I'm pretty sure I shouldn't ask this question, but on the days like the normal months for the swap meet, what type of stuff do they have?
Knickknacks. It's not like that on the normal months.
Oh, okay. So it's
Oh,
more
okay.
knickknacks
I
and
hadn't
stuff.
been to
Okay.
one. I just know they had advertised it at one point. Yeah.
I don't know about you
Okay.
guys, but locally there has been two different places pop up that they say they're selling Amazon returns. So like people return something that they don't want, and Amazon apparently just
Hmm.
does not process that stuff, and they just like
Yes.
mass
They
dump
dump
it
it.
on the
Yeah.
market, and
Yeah,
you
they
go to
sell
buy that stuff
pallets,
up. Yeah.
entire pallets of stuff because it's more expensive for them to try and return it than it's worth. And so
Yeah.
they just sell it in bulk to get rid of it.
So anyway, I walked through one of those stores, and I only mention it because you were talking about like it would be a bad idea to go there because
Yeah.
oh my
Did you bring a
goodness,
truck with you?
just the stuff. I was like, oh, I could use that. Oh, look at that. And
Mhm.
the only reason why I walked out without buying something is because I literally could not decide what to buy, and I wanted to basically bankrupt myself. So yeah,
Yeah.
that was a bad experience. Um, and then the other thing, I'm sorry, I cannot help but share this. Has anybody else heard of Xylus Vices? This is a Swiss-made transformer vice. If you look for ZYLISS, I'll post a link to the demo video. Anyway, I got one and they are amazing. And that's all I'm going to say about it. Thank you. Thank you for allowing me to indulge myself there.
Oh, no problem. We still have the around the room, so if you want to share that, that would be great.
I will try to get a video ready for that.
Okay.
You've reminded me that last Saturday was the annual SCARC. I'm trying to remember what it stands for. Stanwood Camino Island Amateur Radio Club swap meet. And I went to that like I usually do, and found one very interesting item that I picked up, which was a big box full of mostly Arduino accessories. So
wow.
will really help me. Well, I don't know if it'll help me, but it'll be fun to be used with Donna's class.
Excellent.
Cool. Okay. I'm going to move us to the next slide. We do have still around the room, so I'm sure we can pick some of this back up. I need to beg for presenters. In addition to buying t-shirts and swag, Steve's got some open slots for presenters. So if you know of anyone who would like to do presentations, please have them get in touch with Steve at Seattle Robotics Society at gmail.com. In the event we don't have a presenter, we'll just pick from one of these open discussion topics. And if you would like to host a discussion on one of these, also let Steve know. And then this list he's continually updating. That looks like this slide didn't quite get fully updated, but today we have Chas talking about Node-RED for robotics. July, we have portable PC with AI. And August 16th is going to be cryptography. Boy, I can talk. So September on is open. If there's a presenter, let them know. And then, of course, today we have Chas with Node-RED for robotics. And we'll be doing that right after our around the room. So stand by for that. And let's see. That we don't need. So, around the room, does anybody have anything they would like to share?
Oh, yeah, I guess I do.
Okay.
So I know that Donna's got a demonstration coming up, which is great, and I look forward to seeing it, and hers is going to be great because it's going to work. But I know that there is a 3 kilogram sumo class that we're looking at setting up in the future for, for competitions. And well, I mean, let's face it, we're not there to compete. We're there, there to show off what we built. Um, but I started on one. I totally didn't need the distraction, but I saw something shiny, and that happens with me. So, and it's not
Well,
complete at all, but it's an interesting class. You can get a little fun with the motors, when you're dealing with the minis, like you're so weight restricted that unless you have a lot of, and I would say that I don't know, mine is just a Pololu robot, right? It's made for that class. And that's what I'm going to run. I do have some parts and pieces to build one myself, but you're really limited on the amount of materials you can use. Like if you look at the home built ones, there's just not a lot of meat to them, which is fine. They're cool. But you can get a little fun. You can actually start putting sensors and stuff on the bigger class, which is nice. So it's not just like, is there something out there? And I look down. But anyways, so I've got this like, um, it's not done at all. But this is what the size. The motors, I think they're Banebots, if you've ever heard them. I think I got them on Pololu, if I'm not mistaken, or maybe Robot Shop. I don't remember. But it's a decent. I mean, because it's 3 kilograms. I got some stepper motors. I picked stepper motors because I like stepper motors. But also, because they're heavy, they've got a lot of mass to them. And so you want mass down on your wheels, you want to hold your robot on the ground. So it's all 3D printed for the case and a couple different prints. That's not one print, it's a couple different bolted together. And I've pretty much got all the electronics. The only thing I did different on this one, I'll share it if I can pop it out here, is my pop bot. Oh, sorry, there's one screw in it, almost done. You've seen like if you've gone trolling on Amazon for stepper motor drivers, there's kind of a void between like cheap drivers and really expensive drivers. The cheap drivers are like, well, of course, the small ones like the Pololu style A was 4988 or something like that. And then the small little tiny guys, those are good for like 3D printers. And then there's like TB 6500 or 6500 and 6600 drivers, and there's nothing wrong with them, but they're kind of big for the size that I had. So I went and I bought this Pololu Tick T49 driver, and it's a cute little driver. The thing that I like about this driver is it's a controller too. So this it's connected by I2C to the drivers, and I send motion commands to it instead of sending like pulses for, rotating the wheel. And so on stepper motor drivers with like the TB 6600, you send it a pulse for, rotation count, and that depends on like its the motor and like is it eighth step, the quarter step, full step, whatever. um, and then a direction and an enable. But in this case, you power it, and it has like some acceleration, deceleration all built in. If you don't, if you decide to go with like the 6600, you can use Arduino libraries. If you use Arduino, like a cell stepper, and it works out fine, but it's a lot of code overhead, and you got to build your own. Well, a cell stepper has its own acceleration, but it's a lot of overhead. And the nicety about having the external driver is you can send a command to it, and you don't have to sit there and service that command every loop, right? You don't have to sit there and run stepper run for both motors, or stepper run. And if you have slow sensors, which we all do, whether we like it or not, like the time of flight sensors are kind of pokey. They take some time, and you'll notice like if you start hitting that sensor and scanning, you'll actually start missing steps. You might not hear it too much, but you probably are missing steps. So like yeah, usually like the time of flight sensors are kind of slow actually. Like I've noticed, and a lot of the reason I run two microcontrollers sometimes is because like there's the VL53X series of time of flight sensors. If you guys have ever seen those, you can usually get those from Adafruit or SparkFun, and they take enough time. I haven't found one yet that if I'm running a stepper at decent speed, I'm not missing steps that I should be sending pulses. If I'm going at a decent speed, and they're nice. They're like a very common time of flight sensor. Time of flight sensor is like a distance. Trying to find like how far out is something. I found like the VL, well, trade secret here, I guess. Maybe I shouldn't tell you guys, but no, I'm joking. The VL 6180 I found is probably the fastest responding time of flight sensor, and I bought a bunch of them. So if you want a fast, it matters, if you're trying to pull it and do some stuff in between, all the different things you have to do on a loop. It is a fast sensor, which is nice. But yeah, anyways, it's been fun. I totally didn't need to make this. and I'm not competing this year because we're not doing it, but I figured it'd be something to bring. Oh, and by the way, that Arduino stepper motor driver is bonkers expensive, but it is what it is. Hey, James, you got your hand up.
I was just curious what you meant by slow. Like what are we talking? Milliseconds? Are we talking microseconds?
Milliseconds. Yeah, unfortunately.
Really?
Yeah, it's
See,
pretty. They're
now
pretty.
time of flight. This is a light time of flight, right?
I hear you. It is light speed, you would think, but no, they're I mean, relatively slow. Like I actually run a task manager sometimes. I disable a task manager in my Arduino loop. And then I just, you start at the start of the loop, you say, what's my macros? And then, I have like 12 different like points that I monitor. Like here's point 1, point 2, point 3. And I know that point 1 is my startup and point 2 is whatever. And point 3 is, my motor stepper run. And point 4 is my time of flight sensor. And then it just through the Arduino serial command, I just like point, like in Windows, it has its little process task manager and it tells me my loop was I don't know, call it 12, milliseconds, not microseconds. And maybe like 5 of those or 6 of those are the time of flight sensor. So kind of slow.
Wow.
Hmm, yeah.
I'm very surprised by that. I posted a link to a Arducam to a video that a guy is using the Arducam time of flight sensor, and that one seems quite fast. But it's a $50 sensor, and I think I think it's like 160 by 320 or something like that. I mean, it's an array, right?
Yeah.
So maybe the processing on board that one was optimized, related to the cost, whereas the lower cost ones, the little processor they're using like I don't know, an AT Tiny or something to run it. That's really interesting. Thanks for the information.
Yeah. And
so the sensor that you're talking about is a VL6180,
yes,
and that's a laser.
I don't know if they call them lasers, but yeah, it's
I'm wondering if VL is visual laser, but if not, yeah, I'm like, I would think you'd get a better response even with an ultrasonic. I'm shocked that it's that slow.
Oh yeah, you probably would get a faster time. I don't know I don't know if it's COM latency or if it could be because I'm using a library and probably a native fruit library if I'm gonna or SparkFun library. It could be that the library is blocking the loop while it's waiting for a response. And like if it doesn't see something, the timeout it's the longest timeout, like a sonar, right? If it responds faster, if it sees something or if something's in front of it. But if not, it waits till it hits its timeout period when it would expect to reply and then it responds. So it could be library. I don't know. Maybe if I built my own library, it would be better, but I did not because I'm not that fancy.
That's actually, Chas, what I was just going to go down. The path I was going to go down is, is it something where you can trigger it and then come back and read it later, or do you have to continually be watching it the whole time type of thing, right?
Yeah, and it's basically just a call like, what's the distance?
Yeah, okay.
Dropping it into an integer or whatever.
Yep. Cool. Okay.
Anyways, that's coming up. I look forward to Donna's demo.
Yeah.
So we'll see what she did, see how far off I am on crazy person stuff that I'm working on. So.
Okay, does anybody else have something for around the room?
I had a minor question about the competition coming up, the Robothon. Are we still taking registration for robots for that?
Yes.
Okay.
Registration is still open. In all honesty, it'll probably be open right until you get there, but Don is trying to get everybody to sign up early so we know what we got. So
yeah,
if you've not signed up yet, please do so.
I will work on it.
I don't think they ever turned a robot away.
I was going to say that, but then it would demotivate people from signing up. So please sign up. And if you don't sign up, we'll probably still let you run. But you may have to bring us Snickers bars or something. Yeah. There's going to be something to motivate them.
I'd encourage you to sign up even if you're not sure it's going to run.
I mean, exactly.
it doesn't matter if you don't have it with you. Like, heck, I think I have a pretty bad hit rate for like robots showing up at work. Probably like 80% of the time they work and 20% they broke on the way there or when I was there. Or,
I think 80% of the time robot working, that's pretty good.
yeah, I might be optimistic on that one.
I'm not saying I don't believe you. I'm saying
Yeah, I hear you.
robots are just horrible.
Yep. Especially when they're one-offs and hand built like we do, right? It's like if you got a manufacturing line, you go find all the problems and you fix them so they operate reliably. But we're not producing thousands of them. Okay, does anyone else have something? We got some videos we can run too, so.
So yeah, speaking of videos, I dropped a link in. It was before the recording started, so it's like the first link in there. But it's this kind of cool squirrel robot that I learned about from the Cal Berkeley Alumni Magazine.
Oh, cool. Okay, let me go find that. Let's see. Squirrel Berkeley. Okay, let me set that up. Whoops. Stop. Of course, like this time they did not put an advertisement right up front. So let's see.
Are you sharing your screen? Because I don't see anything.
Yep, I'm getting there. There we go. Oops. One more button. There we go.
You know how squirrels can just leap from branch to branch? They make it look so easy, but it's not. There are a lot of forces at play. And if you want a leaping robot to stick the landing just like a squirrel, well, first you have to understand what the squirrel is doing so expertly. This is the Salto robot, a foot-tall jumping dynamo developed at UC Berkeley a decade ago. In 2 new papers, UC Berkeley researchers outline how they studied the acrobatics of the squirrel and trained Salto to land like the rodents. It turns out that squirrels apply a braking force when they land. 86% of the kinetic energy from a jump is absorbed by their front legs. But Salto only has one leg, which is an advantage for its jumping ability, but not so helpful for landing on a narrow branch. To help it stay upright, Salto has a flywheel that whirls a bit like a human's arms, or a squirrel's bendy torso, when balancing. So the researchers took what they found out from branch breaking by squirrels, which also use their legs to prevent over or undershooting, and engineered it into the bot. Watch closely and you can see that the flywheel goes into reverse when Salto lands, and the tension in the legs changes, effectively braking like the squirrel does. Someday, robots with Salto's squirrel-like abilities might be useful for navigating disaster areas, infrastructure inspection, or managing forests, or to explore low-gravity bodies in space, like Enceladus, a moon of Saturn where gravity is only 1/80th of Earth's, and a single jump from Salto would cover a football field. Think of it as one small step for a robot and a giant leap for squirrel kind.
Ah, very cool.
Did you notice it was using a pair of fans for its lateral stability?
Oh, I didn't catch that. I saw the flywheel, but I didn't catch the fans.
Yeah, they look like rabbit ears at the top or something.
There we go.
Yeah.
Interesting. Yeah, cool. Thanks for sharing that one. Does anyone have something else they want to take a look at? I've got a couple other. We got time about 10 minutes or so. So we got time for 1 or 2 more. Okay, let's see. Actually, there's one here, an active ball joint mechanism with 3 degrees of freedom. Let's try that one. course, this one comes with ads.
Do you have old pictures on your PC or smartphone? Then this video is for you. Nobody believed me at first, but now everybody wants one. My friends roasted me for getting scammed into buying a
There we go. Oh, that's interesting.
Here's the ball.
If you want to start a profitable business or make more money at your job, you are.
Okay, well, that was interesting.
So I'm trying to figure out how much bigger the ball is than the drive wheels. Each drive wheel has one circular spot on it, and I'm not sure how many circular spots there are around the circumference of the ball. At least one, probably two, maybe three.
Let's see.
How would you use this in, I mean, it's fascinating that they developed it, but the only thing I can think of for this is if you're trying to do multi-axis milling or whatever, where you're manipulating an object like you would in your hand, but using the robot to be more precise about it. Does anybody know how this would be used?
Oops, sorry
Okay,
about that.
two poles on so that means that the diameter of the drive wheels is half the diameter of the ball.
Yeah, looks like about right.
But it still seems like you would get into situations where it wouldn't mesh. Of course, you can't tell on this picture because it doesn't have the cross cuts.
Yeah, let me see if. Hang on.
I
Let me see if I can
think it's
scroll
pretty
forward to
telling
the-
that they're lifting 300 grams.
Oh,
Yeah.
But
man.
what I will say is, the driving modules themselves, that work as a diff, that's pretty useful as like a, on a robot arm as the wrist joint potentially. I could see that being useful there.
Yeah, I was
Can you
thinking
share a
shoulder-
link to this video, Lloyd, in the chat?
Oh, it's
'Cause I
already
want
in the chat. It's up at the top of the chat. Chris Powell to everyone, 10:15 or 10:05, excuse me.
Chris posted it?
Yeah.
No, that's the squirrel one.
Oh, I'm sorry. Sorry, my bad.
What's the zero backlash one? I thought that's what this was. I didn't follow it though.
No, this is active ball joint mechanism. So
oops.
yeah, that's okay. And actually, the thing that really struck me as far as what you would use it for came from that image right there. That's a shoulder joint.
Yeah,
That's
that can
that's
do
basically
pretty much
your-
everything a human shoulder can do, right?
Exactly. And I think it's probably got, looking at, well, let's hang on a sec. No, that's about a human shoulder joint, about the same range of motion, looks like.
Yeah. So
that's what struck me.
The one that I posted is he ends up making a diff out of it. So like one of the drive units on this one. So it only has 2 degrees of freedom, not this is 3 degrees of freedom.
This is 3'd
right?
off, yeah.
3'd off out of 4 motors.
Right.
So this one is 2'd off with 2 motors, and it's a diff. So both motors drive each degree of freedom, so you get double the strength out of it, which I have always thought was a cool thing. The advantage of that one, the one that I shared, is it's really strong. There's a part in the video where he just like takes a bar to it and tries to break it. And even though it's 3D printed, so like in this one, the each individual tooth or like a very small area of teeth is carrying the load.
Yep.
On the one that I posted, the load is spread out over all the teeth all the time. So it's a lot like stronger. It's a fairly long video, but you can kind of jump through it, I think.
Okay.
There's
Let me
places.
throw it up there real quick.
What if you could get rid of long tent setup forever?
Setting
That's
up
what
tents
we want
should be
in the robotics group. Long tent setup is
zero
such a
backlash.
Yeah, it's pretty cool.
There's
There you
no
go.
level or high point gears. It's not a warm drive. It has
It's
no
6
cables
minutes,
and
so we
belts.
can probably
It can
watch
work
the
at
whole
almost any angle. And I spent over 6 months figuring out this design. Before we dive in, I want to be clear that I'm not a professional mechanical engineer. My background actually is in software engineering. Mechatronics is just a hobby that I do in my free time, and I really enjoy it. So if I got something wrong, feel free to correct me in the comments. Just don't roast too hard. I'm here to learn too. Sometimes you need to transfer torque at an angle. It's useful, for example, in robotic arms if you want to move heavy motors away from the end effector. This helps balance the elbow axis and improve the payload capacity and speed. The most common are bevel gears, but they are not super precise. Belts are quiet and simple, but they can handle much torque and don't like being twisted over short.
That's his design there that he made.
Hope you've seen my video about this inverted belt differential drive. Cables are awesome, snappy and smooth.
This is the one I
They're kind
love.
of a hassle
Look
when
at
it comes
that.
to eroding and tensioning.
So
Plus, they
nice
have
with the
limited
cables.
rotation.
But
I'm
they
sure
do have
there are
limited
plenty of
rotation.
other solutions out there, and I think I found one more. One day, I saw a rack and roller pinion system used in a linear drive. It's very precise and efficient thanks to the rack's special trochoidal teeth design, which lets the rollers engage at just right angle and roll smoothly without slipping. At any moment, at least two rollers are in contact, so you get precise torque transmission without backlash. That got me thinking, what if I could make an angular drive with it? I got curious, started digging into some papers trying to figure out how to build this profile. The tricky part was to make this linear profile work at an angle. My first prototype was based on a bevel gear design. It felt like the most obvious approach at that time, with a conical pinion and a crown gear. Actually, it was working very well and smooth without any backlash. But there's a problem. It has the conical rollers, which are hard to make, and if you 3D print them, you'll always get a seam bump. Plus, there's a plastic on plastic contact, which isn't great. I wanted a simple solution with straight metal rollers instead. So I designed a crown gear for a conical pinion with these rollers. But I kept thinking, is it possible to make a tooth profile that works with a straight pinion? It didn't feel right at first, and to be honest, I couldn't figure out the tooth shape with math. So I brute forced it to verify the idea. And it worked. I was so happy, I thought I had invented something new. I even started thinking maybe I should file a patent. But after a bit of research, I found that it was already patented. So yeah, I came back down to earth real quick. Now I'm not even sure if I can share the STL files. Maybe someone can help me in the comments. This version has a pretty simple pinion, but the crown gear ends up with a complex tooth shape that changes across its surface. So when a roller with a constant diameter moves along that profile, it travels uneven distances at different speeds, which can cause friction or slippage. There are two ways to fix it. Get back to my first version with conical rollers. Since the roller diameter changes with the tooth shape, the problem doesn't happen there. Or we can add multiple bearings on each roller so they can spin independently, kind of like a roller kebab.
Isn't that
This
smart?
example, I'm using several brass bushings. This one is a 45-degree variant, by the way. Then I kept experimenting and built this wrist differential. It uses an 8-roller pinion and 2 crown gears on the side, with 1:1 ratio between them. I've embedded a tiny 8:1 reducer inside each bearing block. To drive this differential, I made this over-engineered double hollow shaft forearm as a demo. I think I'll make a separate assembly video of this wrist. I used 2 roller pinions and coaxial shafts with shifted crown gears to transfer torque without bending any belts. That gave me an extra 2 to 1 reduction, so in the end each axis has total 16 to 1 reduction.
You guys doing really
I'm
well
also
for being
working
not
on
a
a version
mechanical
without
engineer.
belts, so I can take advantage of using odd angles for more compact and lightweight design.
This is the part I liked.
Then I ran a quick torque test and pushed it to 9 Newton meters. That's the maximum what a tiny reducer can handle. The square hole couldn't take it and gave out. To my surprise, the angle drive held up really well. The crown gear had no visible dents or deformation at all.
Gotta love that when the power takeoff gives up
I
before
hope you
your
enjoyed
gears
this
do.
video. I'd love to hear what you think in the comments. Don't forget to subscribe to my channel and check out my Instagram where I share some quick updates.
By the way, that wave drive with rolling elements, that one is, this guy, he goes on about not being a professional engineer and being a software guy. I'm like, you know what? You're doing fine, buddy. No worries.
As you folks know, I'm a software guy. My dad was a mechanical engineer, and he could do stuff like this. I just look at this as like, okay, I see how it works. How you got there, that's dark magic to me.
Did you catch that he was talking about how he brute forced it, meaning that he took a shape and then subtracted another shape from it and then rotated both of them and subtracted again and rotated and subtracted until he had the shape that he wanted, which is like, that's a technique from Tinkercad. You know, you do that all the time if you're doing stuff because you can't do other like more complicated things. So anyway, I was super impressed with that. You know, there's enough there that you could figure out how to do it, but a bunch of people in the comments are after him to share the files or whatever, because I think it would be very useful.
Okay. I think that we're at a good stopping point for a moment. So let's take a 10-minute break. Oops. And we'll come back and we'll get Chas set up with his video. Let me get a timer going. Let's see. Okay. I'll just leave the mics and stuff on, so folks feel free to take a break, and we'll be back in 10 minutes-ish.
Y'all are just being way too quiet today.
Yeah,
What's
I know.
with-
Nobody's talking.
Kind of
Has anybody heard from Bob? Just out of curiosity, I don't mean to like bug, but I keep asking about him doing another vision thing because I'm super interested in that.
He was at our, I think he was at our last Robothon meeting, if I'm not mistaken. We'll have to bug him. We'll ask him.
Which
Bob Cook?
Yeah, Cook.
Yeah. Oh,
okay. I didn't. Okay. Yeah, I've talked to him recently. He's been, sounds like, really busy with work lately. So, but he is around. He will not be able to make it down for the Robothon event, though.
He's out of Vancouver, right?
Correct. Yeah. We should be Vancouver, Canada, so we should specify that.
My wife was telling me that there was a big earthquake indication.
Volcanic eruption.
Well, I'm sorry, a volcanic eruption thing off the coast of Seattle. You guys follow that? Do you worry about it at all, or no? Or is it, does it happen too often?
It's large, but it's on this underwater on the seamount, and so they keep sort of hyping it in the national news, but it's like it's underwater. It's not likely to be a big problem, other than the seismic activity it might connect to on the fault lines. But the eruption of Mount Spur in Alaska is more significant, because if it goes off, it could affect air travel in the Northwest region and Canada. And that is going to go off. We just don't know when yet.
Like Mount St. Helens, when it put the volcanic the dust. That's the issue, is the dust, not anything else.
Correct. Well, it's also Spur is not that far from what town? There's a town, and so they're concerned about the people that are too close to it, that they may have to rapidly evacuate. It's not a huge town, but it's big enough. But yes, the biggest concern is the aerosoling of all the dust and debris. Mount St. Helens went off. It put 1,800 feet of mass into the air. It was astounding how much. I can't remember how many tons of material that was. But yeah, it really made quite a cloud.
People tend to, because I'm in Southern California, as you know, and people go on and on about the danger of the earthquakes down here, and that's absolutely not the problem in Southern California. The problem in Southern California is the fires. The forest fires and the smoke are horrific, and lots of people die and have their life shortened and all that kind of stuff.
Yeah.
So
well, and the reservoirs not having water, that's not helpful either.
Yeah.
I'm sorry. I was laughing, but it's not really funny. But
no, it's funny in a way. I mean, it's funny because it's like, yeah.
Yeah, well, it was bad management. That's the part that is really unfortunate, is they had I mean, they knew about this for several years, and they kept letting it get worse and worse and worse. And I think that's kind of criminal myself, but
about how our dam.
Yeah, both of our local water reservoirs here nearest to me in North County, both of the dams, they've found problems with them. And so they're continuing to use it, but they reduce the water level in the lakes. And it's one of these things where, like, nobody knows how to build dams anymore, apparently, or very few people do. And so they're like, we can't repair these. We have to build another dam downstream and then take out this dam. And we can't find anybody build the dam. And the people who are coding on it want like God tons of money, and it's going to take many, many years. And, it's like, wow, things have changed.
And they dumped like millions
surprising
of gallons of water that we need.
Okay.
All righty, folks. So we got 15 seconds left. We could do a countdown. I'll just go ahead and kill this. Stop
10,
sharing.
9, 8, 7,
no.
6. The video delay will be fun here.
Anticipation. It's coming. It's coming.
There we go. All right. Okay, Chas, you're up.
Right. Zoom share. Do I got sound? No sound. That one. Share. All right. Let me know when you see the screen.
Yep, we got it.
All right. Well, wherever you're at, good whatever the appropriate time is for you, but good morning for us, I guess, somewhat. I'm going to present on Node-RED for robotics. I will tell you that I could have been more prepared for this, if I'm going to be honest. I have no idea how this will go or how long it's going to go. Might run a little short. Certainly am not a professional at this. I would say hobbyist for sure. I'm certain I'm going to leave you with questions that I can't answer. And I know that Google and YouTube are going to be your friends for anybody that needs some follow-on information. I'd say my presentation here is work in progress. Certainly my robot is work in progress, as always. And even what I'm going to present and demonstrate on is work in progress. I would say that my experience for the most part with Node-RED, which I'm going to present on, is just for work, for doing testing, for gluing like applications together as an API. So yeah, and I guess before I move off this slide, the robot there to the right, this is my point of view right now. I took this picture an hour ago or so. And on my desk, I have my Electric Mayhem robot. It's my Robo Magellan robot. So it's the outdoor robot. I did run this last time in the the SRS build challenges 2. And I think I was going to do 3, or I did, and we just didn't run it because there was only one robot. It don't remember. The robot is, well, I'll talk about the architecture here in a couple slides, but anyways, I got my robot on. I had to switch the Raspberry Pi over to my local network, which unfortunately the Wi-Fi is on the other side of the house, so it's not super strong, so I'm not going to be able to dig in too much. Yeah, it's the robot's on Wi-Fi. Normally has its own little hotspot internally. But for for presentation purposes, I have to be on the internet, so I had to put it on my local network. Oops. So let's talk about what Node-RED is. What is this thing? Node-RED's a visual low-code programming framework for event-based applications. I put I copied and pasted right off the Node-RED website. Node-RED's goal is to enable anyone to build applications that collect, transform, and visualize their data, building flows that can automate the world. Its low-code nature makes it accessible to users of any background, whether for home automation, industrial control systems, or anything in between. I use this as like API between, I would say, non-critical applications in an industrial world. So I'm going to go over kind of what it is and what it isn't here. And then I'll, of course, talk about my application. Why do we care about this in robotics, or why do I care? And then I'll do some demonstration. So what is it? What isn't it? I told you that it's a development tool, right? It's a programming framework. Uses these things called visual nodes that you'd wire together that connect things like APIs or web services or databases. It has a lot of different types of connections that it can connect to. If you've ever seen Home Assistant before, I think Node-RED's built into Home Assistant, if I'm not mistaken, or you can put it on there. It's built on Node.js and uses JavaScript under the hood. You can actually write line code in some of the functions. It's popular in IoT. Actually, my first experience with Node-RED was in IoT. The guy named Wellington Duras, I think is how you pronounce his name, did a um, workshop on it.
Cool.
There's a fantastically large library of community contributed nodes that you can just download. It's very easy to create custom nodes, integrates well with MQTT, which I'll describe in a second, HTTP, WebSockets, databases, cloud services, etc. Flexible deployment, you can run it in containers. Actually, I think you can download a container of it just all pre-configured for Docker. I don't run it that way. I run it on a Raspberry Pi. I definitely have it on a cloud server as well, like a Linode, and you can run it on local PCs. It's event-driven architecture. That means it's well, you can kind of do it. You know, you're used to like programming microcontrollers, or if you are used to programming like with the Arduinos, that's you know, it's a loop. You know, single. It's a single loop generally. Maybe you have two loops on a microcontroller, but in this case, it's very event driven. So something happens which triggers other code, or some time, you know, trigger happens and some code runs. It fits into IoT real-time applications. It's has this asynchronous non-blocking by design, efficient handling of multiple data streams. I would agree with that. I would say its cons, while I do not have it running my robot per se, not the nuts and bolts of it, because it's not really a replacement for a traditional microcontroller, or any loop-based programming, in my opinion. I mean, maybe some of it that you just fit into it. I would say it does have like nodes for Raspberry Pi, so you can actually directly interface with I/O, but it's kind of messy for interfacing with direct I/O. It's definitely not ideal for complex, large-scale enterprise systems. I mean, you build a node out and you'll see it here in just a couple screens. It can, it it has its limits on how many flows you can run. Flows can be very hard to manage as your projects grow. Absolutely, like I'll show that to you as well. I mean, it's not for very large systems at all. Not optimized for high performance tasks, which I'd agree. I mean, its key benefit is that it's and very easy to use and it's very UI friendly. And you edit it on the fly. Um, well, you have to deploy it, but uh, JavaScript, single-threaded limitations, Visual Flow Editor can slow down with larger complex flows, that's for sure. And I'm sure you can secure these pretty well, but you know, out of the box for fun, they're not particularly secure. They definitely, I don't even think they come with default security on. I think it's you just pull it out and go to town, or you know, you just launch it and no security enabled. So you'd have to build security around it for sure. I'm going to go into my application, and this is how I'm using it. I'm using it in Electric Mayhem. I was looking at John's remote control on his phone, and I was trying to figure out like how I would do a remote control on my robot where I had a remote control that I could use with my phone. I didn't want to use a computer. I didn't want to use an RC remote control. I have. And I was thinking like, how do I actually, you know, control my robot? In a nice way. But then also I had a bunch of other little things I wanted to do from like a hierarchy thing, like you know, just I'm in this mode or I'm in this mode or this has happened and I want this to happen. Stuff that it's not done as well in microcontrollers anyways. And anyhow, the architecture of my robot is shown in this black blob on the screen. I have one Raspberry Pi, or sorry, yeah, one Raspberry Pi. It has a CAN interface on top of it, like a CAN board that plugs into the top of it. It's running Node-RED, MQTT. MQTT is short for Message Queue Telemetry Transport. This lightweight, it's like a published subscription architecture kind of server, I guess I would call it. And then it has a dashboard, and that sits on a CAN bus, which sits with well, a couple other four other devices. Two of them are RP2040s that have CAN boards on them. Those are the Raspberry Pi Pico. One handles my IMUs, my all my dual IMUs, time of flight sensors, a little bit of like UI with like a OLED and like a rotary encoder to tell my robot like which mode to be in. It also does most of like the subsumption programming. Then the other one does the GPS and the Pixie 2. And then my O drives, my motor controllers for those are, there's 2 motor controllers, one for each motor, and those also sit on the CAN bus. And as I mentioned here, I wanted to be able to control my robot by phone remote control, like a web or app. I needed a solution to easily change code on the fly for sequences at events. If you've ever pulled out your laptop in one of these events and realized you had to make some changes in whatever Arduino IDE, sometimes that's a challenge. You're kind of sweating it because you gotta, it's not hard, but you make your changes, you copy and paste, you edit some things, and you recompile and download. I wanted something, if possible, easier. So let me go to demo here. I'm gonna go kill this. Can just show you what I got. So I'm gonna start with this. So I'm just gonna show you this. This is something that I have running in my house for an API, and this is not robotics. I'm just showing this to you to show you what Node-RED looks like. This is the Node-RED interface. It's a web page, right? Like, let me get rid of this stupid, get rid of this bar. Oh, close enough. It's just a web page, right? And I just have an IP address plugged in to my browser. And this is these are different flows. Flows are, I guess I would call it like a application. It's kind of even hard to say that it's an application. It's more like something I want to happen. And in this case, I have this. Sorry, on the left-hand side, I have all these tools that I can use, like change, switch, functions, filters, calculators, unit converters. You can have different types of tools for networking. This is MQTT, HTTP, in and outs, TCP, serial. You can play audio, I guess, whatever, parsers, storage, backnet. There's some Metasys stuff in there that you don't need. But and at the bottom is my Raspberry Pi IO if you wanted to touch IPO. In this case, the flows kind of start from, well, you can do them however you want, but naturally you normally see them go from left to right. So I have something called a timestamp here. And if I open that up, it says that it's sending out a message payload of timestamp. And down here it says inject once after 1 second. Then it repeats at intervals of every 2 minutes. And I do that because I want this flow to run every 2 minutes. So it injects a timestamp, and anytime anything hits the input of this HTTP request node, it runs this node, if you will, right? And so I'm doing a GET on this Open Weather Map API. It's just a URL. And then from there, that's going to output something down into these functions. And these functions just do some parsing of JSON data and then change it just so that it's ready for what I want it to output to. So here you see on the left-hand side, there's a debug output, and it tells you like this is the output of the JSON data that I just got. So if you're not here in the Seattle area, here's my lat long, and here's my clouds, and it's overcast, and it feels like, et cetera, et cetera. So you see here, like I'm just pulling down some weather data. I'm actually outputting this into something called MQTT, which I mentioned before. I'm going to start up MQTT real quick. Right here, I'm just connecting to this IP address, which is my Electric Mayhem robot. So I'm going to connect, and it's going to run something. It'll update here in a second, but we don't need that. So this is just for fun, for our work testing stuff. I'm going to go over to the Electric Mayhem robot itself. And like I mentioned, this is work in progress. So I have a connection from an MQTT server here. And then from there, why do I have, if your deploy button is red here, you have something that is not, oh, that's because I just moved this. Anytime you make any change at all, you have to deploy it right there with that button, and then it successfully deploys. And then I need to view my debugging information so you can see what's going on here on the left. So I just built this simple dashboard, and all this is doing is it's reading some information from the MQTT server. It's subscribing to a single topic called em/data. It's doing an auto detect. It parses JSON on the fly, and then it outputs it to some functions. And these functions do things like, well, this one doesn't do anything. It's just saying the message payload is nothing. This one is doing some, what am I doing? I'm saying if the message has reset HB is true, then the payload is false. Just, it's some JavaScript stuff. But the real purpose of all of this is to run this UI feeder, which is called, this UI, which I'll show you in a second. So all of this information is just collecting information from MQTT and then placing it on a dashboard and then taking what's on the dashboard and pushing it into MQTT. So I'll give you an example of what that dashboard looks like. Because I built all this, I now get this thing called a dashboard. So it has this web address of 192.168.0.57 port /UI. This is what I would plug into my phone if I was out on the field. I'm like out there. Now, granted, my robot would have its own hotspot, so I'd be plugged into whatever its IP address is. But if I squeeze this down a little bit, it'll kind of give you like maybe an idea of what it would look like if it was on. Uh-oh, why do you disconnect? This is what it would look like if I was out there. Right now, this stuff is 0 because it's not running. These actually should be blinking on and off. I'm a little concerned about that. I'm guessing I disconnected. No, I'm good. Let me disconnect, reconnect real quick. I don't know why I disconnected. All right, so this would be one screen that I would see. So if I had my phone with me, I would click Start, like I want to start the application. And if you notice when I click Start, something popped up over here, EM, which is Electric Mayhem. This node red grabbed that and it took it and published it on EMUI start equals true. It published it on MQTT. Do I need to do that? No, I could have probably just took that from like a website and sent a CAN message. But in this case, I wanted to put it out in MQTT because I have another handler that takes this UI start and then forms a CAN packet and publishes that on the CAN network. So that any appropriate, whatever microcontrollers that want it can see it and do whatever it needs to with that. The other navigation is my remote control. Like I mentioned, I would want to remote control. So if, let's say I want to modify my speed of the robot, I might use my finger and slide this over, and then I have on my MQTT, or the remote speed went to 5, or, sorry, I'm using a mouse here, so there's 2. And then you also have this joystick here. So you could use your finger on this if you had a phone. And you can pull it forward like this. And you'll notice over there that my joy topic, is, let me open that up so you can see it. So now I've got an angle of 69 at a power of 100. If I backed off a bit, my power comes down, my angle would change, and so on and so on. So the idea being that it would take the data from this joystick on this website with my swinger swiping it, it'll chuck that out on MQTT, which is also on the Raspberry Pi, publish that, and then I have a COM handler that takes those subscribes to these topics out of MQTT and then transforms that into CAN messages, but in a way that's kind of lightweight because, on my CAN network, it's just a bunch of RP2040, so it doesn't want a lot of complex information. I pack these down into, to bytes. So I'll take all this and turn it into some, bytes that I publish out on CAN and whatever microcontroller that would handle motor control would read that CAN information and then, turn on the motors at appropriate speeds and whatever turn, etc., that sort of thing. So the purpose for MQTT, while I wouldn't say that I would run my whole robot off on this, if you've ever seen Craig's robot, it is nice to be able to, in a big chunky block, change like basic basic sequences, like, move a lot of code or something. Like, once this sequence happens, I want this sequence to happen, I want this sequence to happen. And it's all very easy to do when you have, maybe that's function, you can go in here and I'm going to delete this connection, and you say, oh, I actually need to switch this and switch it over to something else if something happens. So sometimes it might go over here, and, if not, like, go to change a different, put a different function in here for something else. And then this one I might output to whatever, a delay or whatever function I might MQTT out. And now I'm going to publish it to something else, etc. It's really handy for doing these, very, very quickly changing, like, very high level, choices for your robotics. Don't want that to there. So right now I'd say I'm kind of at the point where my remote control works, and which is nice. The most important part, I can actually use my finger on my phone, and I can send, doing this, I can actually send commands to my robot. Of course, you might be like, hey, Charles, or Chas, by the way, why are you trying to remote control your robot, which is supposed to be autonomous? I will tell you that my robot is probably like 40 pounds now, maybe. And I don't want to carry it around when I pull it out of my truck. So I drive it onto the course, if you will. And when you're done, I also don't want to pick it up and carry it. I just drive it. And then, of course, the best part is when kids show up. If a kid was there and, wanted to play around, I could take that speed way down and go down to 1 and let them play around and drive the robots around. I think it's a lot of fun to see kids' eyes light up when they get to see a robot moving around. Um, so yeah, that definitely went a lot faster than I thought it might. So I guess I'll say that's about all I have for a presentation. Node-RED does have a value, like there are so many videos on it for how to do it, what to do, where to start. I would say that it's crazy easy to start on a Raspberry Pi, even like a Raspberry Pi 3, like an older one if you have that laying around. And just it's a web interface, and there's 14 billion tutorials out on YouTube. Certainly no pro at this stuff, but yeah, I'll go with questions. James, you have one?
Yeah. So let's see. I want to make sure that I don't say this in a way that's pejorative, because I'm very much one of those guys that, like, whatever the best tool is for the job, that's what I'm going to use, right? So, like, I'm not like one of these, oh, everything has to be Python or everything has to be C++ or, whatever. It's like, okay, whatever tool works is great. Having said that, I freaking hate ROS.
Yeah, me too.
Okay, so my question is, ROS is very valuable, and ROS can do a lot of cool things. The biggest thing, of course, is the message brokering service, right? Okay, and I'm just curious, have you worked with that messaging service part of ROS before, and how does MQTT, not, I guess the Node-RED is more like the interface part, but like MQTT, how does that sort of compare, or is there a reason why everybody uses ROS, or is it just because they can be pissy little annoying technical gods?
So I will say that I'm with you with ROS. I have built a simulation and ran hardware on ROS 1, not ROS 2. I tried on ROS 2 and I did a hard stop because they don't really, and I know they added something kind of quasi recently for micro support, but really high level micros, right? And I'm with you. If you don't love Python, I've written applications in Python. It's not for me. It's for other people, and that's cool. I understand why they love it. And I say, do what you love, right? I'm with you. The reason that I like this is because I felt like every time I was using ROS, it was really heavy, and I had to learn like so much stuff just to do it, where MQTT is super lightweight, but it is a communications network. Like the benefit of ROS is that common communication protocol. Everybody always has to reinvent the wheel for COM. I like CAN. Yeah, you have to kind of build your own CAN messaging format, if you will. I mean, the hardware is taking care of you, and the packaging's taken care of you and all that sort of stuff. But you have to build your own protocol, if you will. I actually kind of stole or borrowed or stole. We'll use stole what Greg was using, made it my own because I liked it. But and then I use those common like robot.h header files for like what my protocol looks like for messaging. But yeah, absolutely. I think the reason you'd want to go to ROS for sure. And I would not do this if you wanted to use ROS as like visualization, it's mapping, like the high-end mapping, the SLAM that it does on all the like it has some great tools for like testing your robot ahead of time. But if you don't need that stuff, like I don't have SLAM, maybe someday I'll do A-star or something like that, and maybe I'll have regretted not doing ROS, but I don't see why I couldn't just build a ROS bridge if I decided to go that route later.
Right. Well,
but
and there are 100%. There are SLAM packages. There are A-star implementations in Java. If you go to Node Package Manager, you can find all of that kind of stuff. I love Node, so maybe that's why I'm a little bit biased.
Well, I love it too. It's super easy to get into. I feel like ROS, I mean, get a book and do a project, and now you know basics of how to use it. But this stuff is so ubiquitous in so many different industries that it's very accessible, where ROS is very purpose-built. Like I said, but yeah, those flows, like you said, it's managed palette, I believe, and then yeah, you could just go and do an install, and you're like, what's on the internet? So you do I don't know if it's A-star. You'd have to do a little looking around.
Yeah, just npm I and then whatever the name of the package is, and you're done.
Oh yeah, you could do that too for sure. So yeah, but if I wanted to do something like a Modbus protocol or something, well, there's some whole bunch of Modbus stuff out there that there's you got a link to their website to go look at their GitHub and see if it works for you or whatever. It's just super easy to get into, and it does not take near the investment that ROS does. And if you're not going to use all that stuff that ROS has, I don't see the need. But my opinion also.
Do you control the color scheme of the blocks? Can you group things by functionality and color code it yourself, or is that sort of canned in the Node-RED environment so that you have to work underneath their color palette?
So yeah, this is out of the box. I'm guessing you could change. I don't know. But I would say this is 100% out of the box. I have added some stuff to it. The Raspberry Pi stuff. Well, that came with the Raspberry Pi installation, if I'm not mistaken. But no, this is just straight out of the box. I know that my other one I had added some other nodes in there, so I did some other tools. But if you can manage it, I've not gone that far to look at it.
I just curious. It has a lot of different colors in there, which is really nice for sub-organizing or organizing things by functionality or whatever. So I love this interface, and I remember seeing some of Greg's stuff, and I've always been impressed with both what you've been able to do with this and what Greg has done with it.
Yeah, I mean, so to date, I don't know the answer. Like here's just if I'm just gonna do the most simple thing ever, this is just a timestamp, and I have to deploy this.
What's the rectangle or the square at the end of the block, on the edge of the blocks?
Oh yeah, that's a great question. That enables or disables it, or the trigger. So if it's an output, and I don't want to see the debug, I just do this, and now I won't see the debugger here.
Isn't that great? That is so valuable.
Slick.
And then I just to trigger it. So now it just chucked out a Linux timestamp into my debugger, right? And again, like if I wanted this to keep repeating, because I want it to be something that runs every, I don't know, second, that's fine, And now I deploy it, full deploy, and now it's going to sit there and do that every second. So it's, and it could be doing like API calls or, checking the status of a sensor or whatever.
Now, can you disable that without redeploying it, or if you click that, you have to redeploy every time? Okay.
Oh, no, that does it live.
Sorry. I just saw the thing. I don't know where it is now.
That did
Oh,
do
so
it.
it does do it live.
Yeah. Usually, if I make any change, I'm just so used to redeploying. But yeah, that did it live. So
See, that is so cool. So you can have like all these little debug, nodes on there, and you can, and as you think about like when it starts to get really complicated, how tremendously valuable that can be to just be able to go in there and go like, oh, I want to look at this.
yeah, I'm
Without
100%
having all the
with
rest
you.
of it.
So I learned how to do Node Red writing this writing this API. Like, come on, every single time. Okay, give up and do this. Oops, did I go on the wrong one? Where are you? Oh, broke something. Control Z. This is another Raspberry Pi that I think is acting up. Page. So I learned on this one, but yeah, you're absolutely right. Like I learned just by going through here and like figuring it out on the run and just turning on and on debuggers to find out like what am I doing wrong in this rain parsing function, right? And you can just see my, as I was figuring out JavaScript, because I never wrote JavaScript in my life. I just, was copy and pasting from the internet and just changing it as I go and until I got what I needed done.
So it's great that you're getting into JavaScript because JavaScript is probably my favorite language after like C++.
It is really nice for handling information. Probably the best I've ever
The
used.
thing I think a lot of people miss about the difference between Python and JavaScript is that JavaScript under Node has a just-in-time compiler. So you're running machine code compiled from JavaScript. And if you carefully write your JavaScript, you can get speeds that are like 5 to 10 times slower than like the best C code, right? So it's really fast. Whereas like Python, now if you're using a Python library, like NumPy is super, super fast because NumPy is C++. It's not Python. So, but like if you write a Python program, it's like running at 1/3000th to 1/5000th the speed of a C program, right? So
yeah, 100% with you. I have a Python script that I have that crunches PCAP captures, which is like a Wireshark network analyzer, and it's pretty slow.
and of course, none of what I said just matters because silicon is so fast.
It is.
Moore's law is sort of still holding, and it doesn't matter. Just throw more power at it. We'll build a nuclear reactor. It'll be fine.
Yeah, and we'll start a new one up just for that. Or an old one up.
It's only 3 Mile Island. What could possibly go wrong?
Sure.
So what are your plans with this going forward?
Well, it is just in my case, this is just a remote control for right now. And that's all I need it to be. And that's fine. But I do plan on changing, like, and I know everybody does their own things for like their architecture, their robot control. I decided that you guys know about Dallas Personal Robotics Group. This guy down there named Dave, can't remember, Anderson or something like that. He did a really great video. I probably already mentioned this like a year or two ago on subsumption programming, like a 2-hour video on YouTube.
Nice.
Fantastic. I know it's an older technology. He was using like 68 HC11s or something like that on his. But I like it because it makes really good sense in my brain on how it works. And that's my favorite part is when I really like clicks and I'm like, I really enjoy this. His robots running on 60 HC11s or again, whatever they were, 705s or something, looked like they were very intelligent and they didn't have what I would say, well, I'm not going to take away from the guy. The code was simple enough. And it was just that, that stacking and of all different, servo, mechanisms, all that sort of stuff just looked fantastic. And so I would eventually want to be able to change my my subsumption tables through here, with this. And I think that's easy enough because they're not something that needs to be decided in real time. I think a couple milliseconds is fine in most cases. You just, robot does what it does. It sits there and waits for the next command. So there might be a little bit of a slowdown, but with the ability to run my motor drivers on a CAN controller where I'm like, set the speed and go this until I tell you to stop. Here's your timeout. If you don't hear from me, stop. That sort of thing. I feel like I'm safe in saying that I could send those like really high level decisions, like, okay, I've gone this far, now I need to turn here. Those sorts of things can be handled up in a higher level thing, which I can play and modify. And ultimately, if you've ever, I'm sure you have seen the Robo Magellan competition. These are the sorts of things that I would hope to be able to sit there and just like dial in a little bit, right? Put in some values like, okay, no, I need to go like 23.2 meters and take a turn to whatever 70 degrees and then go 62 meters. And then I start using, then it would know to start looking for a cone and use their vision systems to home in on it. But that's the goal, is to eventually get that higher level decision making out, or at least some of it was here and I could quickly edit it on the fly if I had to, because again, you're like sitting there in game day, I'll call it, wondering like, okay, that's in this pie and that code is, you got 3,000 lines of code and you're trying to find something to make a change. That's not fun.
Yeah, that the subsumption architecture thing, the emergent properties part, I love that. The whole thing, I think there's like 4 or 5 rules that are super simple, and you put them together, and that's how birds fly in flocks, the murmuration thing. And of course I'm sorry, I was thinking about Rodney Brooks. My Blue Sky friend, I follow him on Blue Sky, and we've interacted a couple of times, which just makes me very, very happy. He did subsumption architecture for his early walking robots, Attila, and can't think of the name of the other one. And then on COG and some of the later stuff that he did. So, I mean, it's running in your robot vacuum that's cleaning your house and all kinds of other good stuff.
Absolutely. I mean, yeah, you couldn't said it better. If you're running robot vacuums and stuff like that, it's great for that sort of stuff. Obviously, there's a lot better ways to accomplish the task if you have a lot more complex robots. But for us amateur enthusiasts that are looking for something that's easier to get into, and we don't want to spend 3 years just getting something to turn wheels, I think it's a lot more.
I think that the more complicated stuff. So in my mind, like human beings have I can't think of the word. You hit the knee and your leg jerks. Reflex. We have reflexes, right? And I think the subsumption architecture thing works really nice to embed like reflex type actions in robots, and then let the neural network or whatever that's running above that set the overall goal, but still have the super fast, super hard coded like reflexes that are down below, like no, I'm not going to crush the human because I feel a certain force, and my reflex is to stop when I feel that.
Yeah, absolutely. Yeah, I got a lot of pain in my foot. I'm going to stop pushing my foot down on this nail.
Exactly. Yeah. Or like you jerk your hand back from a stove when you get burned or whatever, right?
Yep. And then then you sit there and like recover from that. You're like, what the heck was that?
Right. Yeah. This is all the stuff that's really this is stuff that has been around since like the 60s and the 70s, and it's been dropped out of hobby robotics. It's been forgotten about, and everybody is just writing very hard coded, or like trying, or they're trying to do everything with a neural network, like end to end all machine learning with no, and this stuff works better when you use it together.
Yeah, I agree. I mean, I understand why it's attractive, right? It's next generation. It's probably going to get you a job if you're in university.
Yeah.
And that's important for a person that's spending 4, 6, or 8 years in university. But I think if you're just like trying to go out there and have some fun and build something that works, that one person can tackle, or maybe two. I mean, I don't have a mechanical engineer. Maybe you have one in your pocket. I don't. You know, I have a Terry that will show up on a Saturday and hang out with us while or a Greg or whoever that might give me some good ideas or make fun of me for my robot, whatever, in good humor. But in all honesty, like if one person's trying to tackle this, it's very easy to get into this sort of stuff that's like fundamental. You don't have to take on the world and like invent something new to tackle a robot that's going to do these competitions that we do, or just roaming around the house, whatever.
I think for me to, like, not even a mechanical engineer, but just like a fabricator, I suck at fabricating things, and I think that's an underappreciated skill. But you're right, ME is valuable, and robotics is complicated enough that it's really hard for one person to do everything, right? You need somebody who knows machine learning, you need somebody who knows classical AI, you need an embedded programmer, you need a electronics person, you need an ME, you need a fabricator, you need like a whole team, and that's impossible.
Yeah, my guilty pleasure is like every once in a while looking on like what new DARPA challenge robots are out there, and they all have, just like you said, the ME, the project manager, the electronic engineer, the coders, a couple of those. They have all these groups of people in there that have these different. They always have like some biology component there in those DARPA ones, but all these different, and you gotta admire all of them are just super brilliant in their own different ways. I am lucky enough, again, plug for makerspaces, to rely on a couple. We have a couple Emmys in the makerspace, and I've had them build me brackets before because I'm like, I don't know how to do this out of aluminum. I need something stronger than 3D printed, and they've milled something for me or something like that because you find out real quick what your limitations are when you're trying to like this.
Was that Dom or somebody else?
It was Chris Hawken.
Oh, okay.
The grumpy one.
Yeah.
Chas, could
sir.
you slowly go over what is where? I got a little lost.
Yeah.
So you have something running on the Raspberry Pi, and that's what you've been showing it pretty much.
Yeah, yeah, I kind of went over that too fast. You're absolutely right.
So what is on all the other little nodes that you have, the hardware parts, I mean?
Yeah, the fun part.
All you have there is CAN, right? So you had to hard code a CAN interface on
Right.
each of your controllers.
Right, you're absolutely right. So I did have to write my own, like you would have to do it for us or anything. I had to write my own application that's running on the Raspberry Pi that does all it's a COM handler that translates the CAN messages to MQTT. So there's an application running on there that's written in Python that handles all CAN to MQTT like traffic back and forth. So if something happens on CAN, matter of fact, for some reason, I wonder if let me go smaller. Let me reset something real quick. I don't know why it's not running, but we'll turn this off real quick. Oh, and no, that's going to kill the dashboard, but MQTT should start back up here shortly.
So,
but anyway, so what happens is, sorry, I'll go back to here. So right now there's one controller for this controller here, and I'll just go through the lineup now that you guys have seen everything. There's one controller, it's an RP2040 that runs like sensors, right? That's all it does, and it has a CAN interface, and then it has a common header file that it shares with all these devices that understand, like if I send these frames, this is like a motor stop, or this is left motor proceed at 20% or something. This one, most of the decision making happens on controller one, like the real low level stuff, the motor driver stuff. And then like what state we're in, like should I start or not, or what application am I going to run? Because I have like this can run 3 different Seattle Robotics Societies like competitions. So I set that here, and so it's just kind of got this like little UI thing, my time of flight sensors for distance, and that anything it needs from another device, or it either reads off the CAN bus or it sends it through the CAN bus. So it transmits like motor drive commands through the CAN bus. And the CAN bus is just a 2-wire, like your car, right? It's the same thing as your car practically. Not quite, but close. And then the controller 2 does stuff that I consider slow, that slows down my loop too much. Like the Pixie 2 is crazy slow. I mean, thought the time of flights were slow. The Pixie 2 takes a long time to get data back and forth. And the GPS is a little bit slow because its driver does a lot of blocking, unfortunately. And that's fine. I just got a Raspberry, another RP2040 out there. It doesn't do a lot. It just handles all the slow stuff. It also takes care of another time of flight sensor for that. I didn't put it there because it's not doing anything. And then there's a Raspberry Pi 5 that has a CAN interface. It has a Python application that's running CAN to MQTT like traffic back and forth. So if this is started up yet. So this is data right from the CAN bus. So you'll see it changing. I don't know how fast it'll update. But right now it's only sending some basic functions, but anything on the CAN bus that I'm filtering and I want to see that should end up in MQTT shows up here. So my COM handler doesn't look at a lot of different stuff that just has no rights being here. This MQTT, by the way, MQTT Explorer, this isn't the actual MQTT server. This is just like just a subscription application. So I just connect to an MQTT server, and then I'm just basically subscribing to everything. I'm just looking at all the information coming to it. And so this is what's coming on my CAN bus, right? CAN ID 3 function 0. Yeah, it doesn't matter. But so all the data that I might want to see on there. And again, filtering down to CAN messages that should end up there only. From there, the MQTT published subscription server, that will interface with Node-RED, or does interface with Node-RED right now. That's Node-RED just talking straight to MQTT. So MQTT is the bridge between the CAN bus and everything. And then from Node-RED is where the dashboard comes. And when Node-RED, like let's say I use my my toggle up to my joystick, it formats the CAN messages with that Python CAN handler to then transmit back onto the CAN bus. And so if I said go forward at 70%, that would go down the CAN. It'd go down to this controller that's subscribing to that and say, oh, I need to go forward, and I'm in the appropriate mode because I'm in test mode. And then it would say, okay, on motor 1, you have to go 22%, and based on the speed, and motor 3 you got to go 33% or whatever it is, math it out.
And it just publishes that to the CAN bus.
Exactly.
And your O drives subscribe to that.
Exactly.
So does anything go, let's see, from controller 1 to the Pi 5 and from there to the O drive, or does O drive only listen to controller 1?
O drives only listen to controller 1 because it.
So all of the stuff in your diagram, when you have all those graphical connections, all of that is on the Pi 5, right?
Yeah, all of that stuff's on the Pi 5.
So let's go back to that diagram. I want to understand why there are so many little pieces.
Which diagram?
The one you draw in Node-RED.
So this one?
Yeah. So what are all these little pieces? Let's see.
Yeah.
They're all MQTT nodes, right?
Yeah. Yes, that's correct. So this is an MQTT. This is a node for transmitting MQTT out. So it's pushing out to MQTT. And then there's these MQTT. And so this is all my output to MQTT. So it's taking the joystick position. It just changes a little bit to be within like the size that I wanted. I don't want to hit a bunch of decimal points or anything. This is just, robotic.
So where is the physical joystick?
Oh,
that's on your phone, right?
Yeah, it's on my phone. It's on anything it's just on the UI. So it creates this, whenever you use like UI component, that automatically creates this dashboard, which is again still on the Pi, and it's still on the website.
So it publishes that as a web page.
Yeah, absolutely. And then
I see. So all you're doing is going to the web page on your phone, and you have a bidirectional connection there, but the changes are already on your Pi then, because it's
Correct.
published to the web
'Cause
page.
I'm connected. Yeah, the Pi is the web page, if you will.
So go back to your drawing again.
Yeah.
So the joystick is on the Pi. The speed is also on the Pi. It's from the same web page.
Yep.
Then all these little guys. Debugs are. So maybe pick one that has more stuff drawn on it, or maybe that.
Well, there's not a lot on here. So here's
All of
the
this.
here's the dashboard, right? So it's kitting. What it's doing here is this is taking from MQTT, taking the inputs, and it's finding it's like sequencing out all the stuff on MQTT that would be like, what sequence number am I? And that'd be something that would pick up off the CAN bus being published by controller 1. The bearing would be published by controller 2 because it does, it's just looking for CAN ID. It doesn't care where it's coming from. It says, oh, this CAN ID came up and it had this data that I want. So I'm going in the Python client COM handler handles that. But it's picking up, it says, oh, I see bearing. So I'm going to publish bearing onto my dashboard. And so there's not a ton of control here. You're not actually seeing the robot being controlled here other than sending stuff to the CAN bus, and then the controller 1 decides what to do with that right now. And then so distance to target, and then I have some other functions here, and it's just showing me this is my heartbeats, just showing that both my controllers are up and alive and it only can tell that by looking for the heartbeat CAN messages on the CAN bus. And so if it sees that, it says, oh, yeah, controller 1's alive. Yep, oh, controller 2's alive. And I'd want to see that before I hit start, right? Just wait.
Right.
And then I have some other XY stuff that I'm working on for some mapping because I'm hoping to like start integrating some mapping. I'm not quite there yet.
So Doug, the thing about this is that it's super, super powerful because you can bring to bear all of the power of the browser, right? Like, so your browser's running, even in your cell phone, browsers have a lot of, capacity, but especially like on your PC. So, I've seen things like a little 8266, ESP8266, which is like, doesn't even have the processing capability of a Raspberry Pi, but it's serving up a web page, and the web page then goes out and grabs a bunch of code from Google for generating like really beautiful graphs, right? And so in your browser, you just get a sequence of numbers from the 8266, but it's presented in this lovely, user interface. There's a thing called Chili Pepper, which uses ESP, I think 32s to run CNC mills, or like 3D printers or whatever, and it pulls down code from the internet to provide 3D visualizations of the G code. So you can like see a 3D visualization of the mill and where the cutting head is going to cut, and like what the layers are going to end up building up, and like see like the whole, what the part's going to look like and the whole thing. And that web page was served from the ESP8266. So you can, walk up with your cell phone, hit the IP address, load the libraries, look at the visualization, control everything.
So wait a minute. The visualization, is it running on a server somewhere?
No. It's running in your browser. Like 3D graphics in your browser, like OpenGL or whatever.
In your browser. So like on your phone in this case.
Could be, or on your PC, either one. Whatever.
But it's getting data from a very small microcontroller that simply has this capability of
just regurgitating a web page. Yeah. And the people think that web servers are really complicated. They're simple as hell. All it is grab a file and squirt it out the internet connection. And then that goes into the browser, and then the browser turns around and grabs like these huge libraries off the internet, and does all kinds of, really cool things with it. It's absolutely amazing what you can do with this model.
I mean, this is the idea, right? Like this is anything you're just looking at. Normally we wouldn't be looking at on a computer. Like I want to be able to do this, right? And now it's sending these messages on the CAN bus to my controller. You know, I didn't have to hard code this. I just dropped some UI elements. It made the web page for me. And now I can control my robot from my phone. And, you know, in theory, if I needed to like start, stop it, you know, instead of like going down and twiggling on, you know, I actually have the ability to start and stop my robot right here on my phone.
And what is the tool you're using on the phone?
It's a web browser. I'm just going to the Raspberry Pi's IP address.
And so,
Right,
so
but
there's
how
there's
did you
another
make-
example of how
how'd you make
brilliant
the
this is.
code?
No, I'm sorry.
What the code that's running on your phone? It's okay. It's a
That's
web
the point.
browser.
It's a web browser. There's no code. I didn't have to install an application.
Well, where did the UI come from?
It comes from Node-RED. Node-RED has
Well,
something
Node-RED
called
makes
Packet.
that stuff. Okay.
Yes. Mm-hmm.
Yeah. So there's all kinds of sources for things. I probably distracted you by mentioning like libraries from Google or whatever, but like Node-RED, just from a little bit of documentation that I've read, has a bunch of different controls like that are interactive that you could do. And just to draw a line under it, another beautiful part of all of this is there's no permissions, there's no security, you don't have to install an app, you don't have to know how to build an app. You just use your browser, you're already done. And you can't do this from a local source. But if you're pulling a web page, so what you can do is you can set up a web page on like GitHub, which is served from an HTTPS connection, from a secure connection. So use GitHub, do a GitHub web page, you get an HTTPS connection. Now that web page can access all the sensors in your cell phone, the accelerometers, the camera, you can do the sound, so you can do voice to speech or whatever. And then that web page can have code in it that goes out and grabs stuff from Node-RED. So your web page from GitHub, which is secure, can you have to put a special code in it, but whatever, grab insecure elements from your local device and make use of them in that web page. So you can build just unbelievable stuff with this capability.
Wow. So Node-RED can be installed on a container, run on your laptop just for testing out and having fun. If you decide that it's something that's interesting, you know, throw it on a Pi or wherever. Couldn't agree more. I probably gave you more questions than answers today, but we're over time, and I would be happy to talk about more elements in the future. But yeah,
So,
thank you guys for that and all the great questions.
Yeah, no, thanks for the presentation, Chad. What we can do is I can go ahead and end the meeting. And if somebody wants to hang around, I can, hand off the meeting, to somebody else, and then you guys can keep talking. And folks who want to, fade away for the weekend can do that. So
I have Girl Scouts for my daughter, so
okay, so you got to run.
Yeah.
Are you selling cookies?
We're over, but I still have some left over if you really want a fix.
I probably shouldn't, but I do like their.
But you're thinking about it.
I didn't realize your daughter was in Girl Scouts, or I would have bought cookies from you. Remind me next year.
Don't worry, I will.
Or the next campaign.
Yeah. Awesome. Well, thanks, guys. Yeah, thank you for all the great questions. I really appreciate your questions and your comments, James.
Yeah.
And Doug as well, of course, and Terry as always. But
thank you for sharing. I think that's fantastic. I really do.
All right, guys. Take care. Have a great weekend.
Awesome. Thanks, folks. See ya.
Bye.
Bye.
Yeah.